Okay, we're going to start Chapter 2, which is our beginning point of this course, Math 1324, Business Economics Mathematics. We're going to start with, where is a system of linear equations and matrices used? Because the whole chapter is regarding working with a matrix or a system of equations. So before we get into more definitions, let's just look at where we see them. In production, we always look for optimization. In making an Excel sheet, we're looking at what is the profitability or production as well. And then we even have a band. A band is unique linear functions that work in tandem with each other to create a design or a picture or whatever in that process of marching. And of course, we have it for business. And in business, we always look at our animals and our products and everything that the farmer does. So that's what a system of linear equations can express. So all of these things are linear functions that can be constructed to represent a desired outcome. And that's what we're going to be looking at. So the system of solution of the linear systems by the echelon method is our first attempts. And this means by hand. Later on, we'll do the calculator and it'll be a whole lot easier. But first, we have to learn the concepts of what we're doing. So we're first looking at the types of solutions. The first one is unique, meaning one solution pair, because we're talking about two variables at the beginning, that are in both linear equations. As a solution. And then we have the next one, which is inconsistent. This usually means that we have no solution. For the system of equations. And then we have, of course, dependent. And that means many solutions are possible. And usually in a two-variable system, all solutions. All right, so graphically, and I got this from the textbook, we can see a unique solution. they cross, the lines cross at one point only. Here we have inconsistent, no solution, and they're parallel lines. Never cross. And then we have this one, dependent, all solutions. All right. Well, what are we talking about in finding these solutions? To find these solutions, to find the type of solution, we use the transformations of a system. In other words, we manipulate by multiplying, by multiplication, then subtraction, to isolate one variable. And the steps are as follows. Interchanging any two equations. That means that we can move the order. Multiplying both sides of the equation by a non-zero real number. That means adjustments. To allow subtraction. If my pen could write, right? And of course, replacing any equation by a non-zero multiplier of that operation plus a non-zero multiple of any of the other equations to create the new line. All right. Well, we know these transformations as the echelon method. And it is when we use transformations to isolate one variable in the system. To evaluate the type of solution possible. And that's what we're going to be doing. And these are going to be easy because we just want to learn the process. We're going to solve this system by the echelon method of the two equations of two unknowns. Two unknowns mean they're linear. They are linear. If they're three, well, then we've got something else. We've got a three-dimensional type movement. All right. So we have 3x plus y equals 11 and 4x minus y equals 10. And we notice that we can combine them and make a new line for that value. In other words, I'm going to add them vertically. Well, that means that I can divide by 7, and I know that x is 3. And I know now that I'm going to have some kind of unique solution. So I'm going to use substitution. Now this one is easy. That's how we start. Use substitution for x equals 3 into one of the equations. So I do 3 times 3 plus y equals 11. And then I'm going to have 9 plus y equals 11. I subtract 9 from both sides. Then y should be 2. So my solution is unique. And we write it in ordered pair as a 3 and a 2. But we also do the last step, check. I put a K first. I was going to abbreviate, and I don't want to. So we're going to use the 4x minus y has to equal 10, and substitute 4 times the 3 minus the 2. And then I'm going to have 12 minus the 2, and sure enough, it checks. Therefore, my unique solution is 3, 2. Again, nothing hard. And we're going to do, of course, another example. So in this example, we don't have it as easy as we did on the first one, but we notice that we have a negative 3y, and we can convert it to 12 by multiplying it by 4. So this would give me 48x minus the 12y equals 48. And then bringing about the next one, and I add, I'm going to have 50x equals to 100. So if I divide by 50, I get a 2. And we can see that we can manage this very easily. So now I have one part of the solution. So my next step is to substitute x equals 2 to the equation. 12 times the 2 minus 3y must equal 12. 24 minus the 3y equals 12. I subtract the 24, and negative 3y is equal to negative 12. Y then is positive 4. All right, because negative 3 times a negative 4 will give us, a 4 will give us a negative 12. So then I know now that I'm going to have a 2, because the x is always first, and the y is 4. And now I'll do that check. 2 times the 2 plus 12 times the 4 should equal 52. 4 plus 48, in fact, equals 52. All right. We're going now to this one. And we're going to check our answers. So in this case, I'm going to multiply to get rid of the x's. I'm going to multiply by a negative 3. When I do that, I'm going to have a negative 12x, a negative 9y, and a negative 27. Now, in doing this process, know that you must do it to every term. Every term. And then I'm going to bring down the next one. I'm going to add them together, and this zeros and this zeros. So I have 0 equal to a negative 15. Well, that's not true. So, no solution. This is inconsistent. Because 0 can never equal 15, negative 15. All right. So now we have some of the space out. Now we have some with fractions. And we're not going to worry about these fractions because we understand only the math. only the math. And we're going to talk about an LCM, and it's called the least common multiple. Now, these problems are not made to give you anxiety. It is only for you to recognize what you can do. Well, our first step is to remove the denominators. To remove them, we're going to multiply by the LCM. Well, the first line, the denominator is 3. So our LCM is 3. I'm going to multiply everything by 3. Well, the 3 cancels the 3, so I'm going to end up with x. 3 times y is a positive 3y. 3 cancels the denominator 3, and I end up with equals 5. This one, on line 2, the denominator is 7, so my LCM is 7. If I do 7, I'm going to end up with x plus 7y equals a negative 3. All right. Well, I notice that I have singular x's. So I'm going to say line 1 minus line 2. And I'm going to have x plus 3y equals 5, a negative x, a negative 7y equals, and a negative times a negative is a positive 3. All right. Well, this zeroes out, so I'm good there. And I end up with a negative 4 equals 8. And that's a y, sorry about that. If I divide by a negative 4, then y equals a negative 2. So I have one part of this solution. Now I'll figure out what the x is by substituting. And I'll use the first one. So I'll have x divided by 3 plus a negative 2 equals 5 over 3. All right. So I'm going to add 2 to both sides. So x over 3 equals 5/3 plus 2. Well, plus 2, we're going to change to 3's. And that's going to be a 6 over 3. All right. So now what I have is x over 3 equals 11/3. Now, because the denominator is 3, I'm going to multiply both sides by 3. So that x then is 11. All right. So I have a unique solution of 11 and a negative 2. And of course, we already know we've got to check it. So we're going to check. So to do this, I'm going to use the other one. X over 7 plus y equals a negative 3 over 7. All right. So I'm going to have 11/7 minus 2 equals a negative 3/7. Well, a negative 2 over 1, and we're doing 7 over 7 to make an equivalent fraction, is a negative 14 over 7. 11/7 minus 14/7 equals negative 3/7, and that is true. So it is a unique solution. All right. Now, we're going to start the second part, and I'm going to start with first talking about integral solutions. And what I want to discuss first is we had two variables, X and Y in our system of equations. And we had two equations in the system. That afford a possibility of a unique solution. All right, the possibility of it, because we have two rows and two variables. Well, what happens when we have three or more variables with two equations in the system? Well, this question leads us to a dependent system. Occurs. And this means there's criteria to follow. Now, always, as you were growing up in math, they always said X is the independent variable. Well, in this case, the driver of the dependent system, that means many solutions, last variable and in the system. All right. So in this case, we're not isolating X or isolating Y per se, but we are looking at using the last variable as the independent, the one that changes and causes the other two to exist. All right. So I am talked for 23 minutes now, and I'm going to stop right there, and we're going to start up on part B of section 2.1 on the next half with the examples of dependent systems. Thank you.